Hi all! As responsible users of HPC systems, we want to make the most of our computing resources by making our runs give us the information we need using the fewest resources. Today we are going to talk to you about how to improve the efficiency of your HPC runs using Trenza Survey. Survey is an HPC performance tool from all of us at Trenza Synergy. Survey collects a broad series of metrics to give you information about your run's use of MPI, I/O, OpenMP, and memory resources. It also gives your run's affinity information, that is, how its ranks were assigned to the HPC system's cores and the balance of its NUMA resources. After the run, Survey outputs a report of the most important results that it measures. You can use this information to get a broad idea of how your run uses the HPC system's resources and what adjustments that you may need to make in order to improve the efficiency of future runs. The first section of the survey output contains some metadata that will help you identify the run, including the start and stop times and the resources used during the run. The next section shows you the run's balance of MPI, I/O, and compute resources. The MPI percentage is calculated by determining the amount of time spent in MPI operations and comparing that to the overall job time. A high percentage of MPI usually indicates that the application is spending most of its time passing messages between nodes instead of doing other kinds of useful work. This usually is not a good sign of resource efficiency. To improve the efficiency of future runs, you could try decreasing the number of MPI ranks to see if that decreases the MPI percentage of total runtime. Some applications make automatic adjustments to its workload depending on the number of ranks, so decreasing the number of ranks will not always decrease the MPI percentage, but you can use Survey to figure this out. Conversely, if your MPI percentage is low, you may be able to add more ranks to your run. The I/O percentage, similar to the MPI percentage, tells you how much time the run is spending performing reads and writes. One common cause of I/O activity is creating visualizations with the run. If you have a high I/O percentage, you may want to decrease the visualization granularity for better run efficiency. But if your I/O percentage is low, you might be able to increase the visualization granularity. Again, you can use Survey to see what happens to the I/O percentage as you change your run's visualization settings. The compute percentage is the percentage of the total job time after you subtract the MPI and I/O times. In general, it's good to have a high percentage of compute time. This means that the run isn't spending all of its time doing MPI or I/O operations. However, a high compute percentage really only tells you that it's not spending a lot of time in MPI and I/O operations. To determine if the compute time is actually being spent efficiently, you need to look at other metrics. If the application has OpenMP operations, the next section of the survey output will show you how much time was spent in the OpenMP part of the codebase. OpenMP code typically performs parallel operations on threads within the node, so this is a very broad measure of the intranode parallelism of the run. The next section of the survey output gives you a breakdown of the average memory usage per rank of the application. The first line tells you the estimated amount of physical memory available to each rank of the node. Survey determines this by measuring the amount of free memory available on the first node of the run just before the run is started. Then it divides this number by the number of ranks on the node to get the estimated memory available per rank. The next line tells you the usage max average, that is, the maximum amount of physical memory used by each rank averaged across all ranks of the run. Also shown is the percentage of this value compared to the estimated memory available per rank on the node. You obviously don't want this number to come close to maxing out the memory available to each rank of the run. A high percentage of memory usage indicates that each rank is doing a lot of work, and this can make your application take a long time to run. If your memory usage is too high, it could exceed the safety margins of the HPC system, which then might cancel your job midway through your run, losing both time and work. For many applications, increasing the number of ranks for your job will decrease the amount of work per rank, which should also decrease your memory usage per rank. Of course, this depends on your application and how it scales when you change the number of ranks used. Conversely, if you are only using a very small percentage of the memory available, this indicates that each rank is only doing a small amount of work. This could make your application run quickly because the work is spread out across many ranks. However, there are a few things to keep in mind. First, keep an eye on your MPI percentage that I mentioned earlier. A high number of ranks performing a small amount of work each could increase your MPI message passing traffic. At a certain point, this traffic can actually increase your total runtime. Second, using a lot of ranks for an application may affect the ability of other users to be able to run their applications. Particularly on busy HPC systems, you will want to be a good citizen and use only the number of ranks that are really needed by your application. So if you have a very low memory usage percentage, you may consider decreasing the number of ranks used by your application to ensure that the overall resource use of the HPC system is spent more efficiently. The next line is similar. It tells you the average physical memory used by each rank, averaged across all ranks of the run. Finally, Survey gives you the average virtual memory allocated to each rank and how that compares to the physical memory available to that rank. Remember that virtual memory includes both physical memory and disk space used as memory. For an efficient application, you don't want your maximum memory usage to exceed the physical memory available. You don't want the application to swap between physical memory and disk because this will slow down your run significantly. The next section of the survey output contains information on the run's affinity. That is, you want the cores of the HPC system to be assigned efficiently to the ranks and threads of your run. In a pure MPI application, you probably want to use exactly one unique core per rank of the run. You have more than one core assigned to the rank, the extra core will probably not be used by the rank and will represent a wasted node resource. If you have a core assigned to more than one rank on the node, then the ranks will need to compete for the core's resources. This could slow down your run significantly. If the cores are not pinned to specific ranks of the run, then you don't really know what happened. The cores may have been used efficiently, but they might not have. In general, in a pure MPI application, we recommend pinning exactly one core per rank in the run for best performance. In a hybrid MPI OpenMP application, each rank will usually have multiple threads assigned to it. In this case, you'll usually want to have one core per thread pinned to the rank so that each thread will have exclusive use of the core. The method used to pin cores to ranks is highly dependent on your computing environment, the type of scheduler you are using, and even your MPI implementation. Some HPC environments really do a good job of automatically pinning the correct number of cores to your ranks. Other HPC environments will not do this for you automatically. In this case, you may need to figure out the commands that will work for your circumstances. When experimenting with these commands, you can use Survey to determine the effect of those commands on your runs. And that concludes our introduction into how to use Survey to make your runs more efficient. If you have any questions or comments, please leave a comment below. And if you like this video, please give it a like and subscribe to our channel. Thanks so much for watching.